This is Algorithmic Fairness and Recidivism Prediction Scores by Aaron Moskowitz, Finn Nguyen, and Charlie Benhart.
This is our capstone project for the graduate course Causal Modeling and Machine Learning, taught by Robert Osazuwa-Ness at Northeastern University, Curry College of Computer Science.
We focus our project on recidivism in the COMPAS dataset. A quick background, COMPAS stands for Correctional Offender Management Profiling for Alternative Sanctions, and it predicts scores for recidivism, both for violent crimes and nonviolent crimes. It's created by the North Point company, and it predicts the likeliness of a convicted criminal to recommit a crime in the future on a score of 1 to 10. The wide use of these scores has led to questioning of potential bias. In 2016, ProPublica found that these scores flag black defendants as being 2 times more likely to recommit a crime than white defendants. Although their findings were significant, more recent work questions ProPublica's methodology. One particular criticism was that they assumed linear age, which may have led to downstream issues when predicting recidivism. Although some of this more recent work criticizes ProPublica, it also criticizes further the original COMPAS scores, particularly for being very untransparent. The features included in the COMPAS dataset are personal attributes such as age, gender, race, and marital status, previous criminal record such as prior counts, felony counts, jail times for greater than 30 days, and prison sentences, and current arrest data such as probation status, custody status, and crime degree. Some of the features that are included in the COMPAS score, in predicting the COMPAS score, but are not publicly available, include around 137 different questionnaire answers pertaining to personal questions about the particular criminal.
The problem statement we're pursuing is to evaluate the fairness of utilizing the number of prior counts to inform risks of reoffending with respect to race and gender. We intend to recreate traditional metrics of bias evaluation and also incorporate causal inference fairness evaluation into the problem using techniques from the course. We analyze bias with respect to 3 different classes of interest: race, gender, and a combination of race and gender. We explore the relationship of 3 causal relationships: indirect impact from the class of interest to recidivism predictions, combined indirect and direct impact from the class of interest to target, and completely unaware race to recidivism predictions. The analysis plan is as follows. We intend to analyze combinations of racial and gender bias. We use 3 combinations of structured causal models with 5 different types of analysis. First is indirect by race and gender. Analysis by 3 classes of race, gender, and then race and gender is conducted. Then direct by race and indirect by race and gender. Analysis just with this 1 class race. And then unaware by race, where analysis of only 1 class, race, is used. Each are evaluated on fairness.
The data we use in particular is over 6,000 records, the 3,000 being African American inmates, and over 2,000 being Caucasian. Just under 50% of the individuals in this sample of the population reoffend. The particular feature set that we use, the target variable is 2-year recidivism, so whether or not a criminal will recommit a crime within 2 years. The sensitive variable that we're evaluating, which is race, and 3 more observed variables that we include in our model: number of priors, age, and gender. We also construct a bias data set in order to make model evaluation a bit simpler. We simply just label all African American individuals with a positive recidivism score.
The fairness measures that we intend to use are first the baseline measures, being false positive, false negative rates, and prediction distributions across protected classes. This is similar to the ProPublica study. On top of that, we intend to incorporate measures from this class, causal measures, such as total causal effect, the natural direct effect, and the natural indirect effect, counterfactual fairness, and finally necessity and sufficiency.
Pre-processing of our data involves first subsetting the data to just include races that are African American and Caucasian. We then break down any continuous variables into categorical or binary variables. Age is the only categorical variable with more than two options, broken down into those under 25, those between 25 and 45, and those older than 45. Number of prior counts is broken down into just 0 counts or greater than 0. We assume binary gender, and we assume reoffending in 2 years after parole is also a binary.
We tested 3 structural causal models, with the first being an indirect model, where race and/or gender, as well as other controlling variables, impact previous counts, which in turn impacts the recidivism predictions. In this way, there'll be 3 types of analysis on this SCM. This is analysis of an indirect relationship of race, an indirect relationship of gender, and an indirect relationship of race and gender together. Next, we have a direct and indirect model to analyze race, where this takes the indirect model and adds a direct path from race to recidivism predictions. Finally, we have an unaware model, which has no causal path from race to previous counts, nor the recidivism predictions. When evaluating the indirect model by race, we saw a small but non-zero false positive racial gap and a large counterfactual intervention effect. This is indicative of an effect of race on the model's forecasts. In the least, this is due to an indirect effect through previous counts, but more analysis after this point allows us to better conclude on the existence of unobserved paths of race to recidivism predictions. And with a probability of necessity, sufficiency, and a combined necessity and sufficiency of a middle value between 0 and 1 close to 50%, this isn't indicative of existence of those relationships or those relationships not existing. And there's often similar, but not always the same results across other dimensions of analysis. Next, we have the indirect model results by gender. And here we see a small but non-zero false positive and false negative gap. However, there is a large counterfactual and natural indirect effects on gender, where being male does cause some bias with having higher recidivism predictions. And a value of 21% for necessary and sufficient is evidence that someone's gender is definitely not necessary and sufficient of them recommitting crimes through the model. Next, we have results with the indirect model through both race and gender. And here we're able to see that the false positive and false negative gap is combinational, so only including the most interesting results here. So for example, the gap between African Americans versus Caucasians among only females was not that interesting, so the results aren't listed here. And we saw some interesting results of bias against African Americans based on gender, covering all of the large terms here on this page. And this is across both male and female. However, we did see negative, false negative, and a low counterfactual value for African American females, which may indicate less bias against them. So in the very least, we see no indication that African American males are given leniency in this model. And for additional results, we did see an unexpectedly large negative indirect effect of both Caucasian and African American females. And this seems to contradict some previous results on being male has high effects increasing recidivism predictions. And finally, The results of necessity and sufficiency tended to be square in the middle between 0 and 1, but we did once again see strong evidence that a necessary and sufficient condition of race and gender together does not cause changes to the recidivism prediction. Next, we have our second structural causal model. This is where we have a direct and indirect model to analyze the race variable. All indicators of racial bias are very large, and this is very much expected. Furthermore, the direct path further increases bias in the counterfactual intervention effect by race from the indirect path we had previously seen. And once again, we see evidence that a necessary and sufficient impact of race affecting recidivism is not present in this model. Finally, we have our unaware model results to analyze race. We saw large counterfactual intervention and natural indirect effects, and this narrows down the false negative gap from being partially identified in the indirect model as an indirect effect, but we're also discovering here that there is a racial bias through a non-observed path, not including variables or path described in any of our 3 SCMs. From this analysis, we have 5 main conclusions. The first is that we could find the expected direct and indirect effects of race through their associated models, especially through the natural direct and indirect effects. And this once again enforces how racial bias will be introduced if race is directly included in a model. Secondly, and more interestingly, if the number of previous counts is used at all for recidivism risk scoring, this feature will introduce racial bias into the forecast unless otherwise addressed. And this is regardless if there is a direct link from race to previous counts or not. Third, we found significant evidence of unobserved causal relationships from race to recidivism, and this is even beyond mediation or being an unobserved parent through prior counts. Fourth, we saw significant evidence of bias against males in the indirect models. And then fourth, there is intervention as well as traditional metrics that show there is a bias against African Americans across both genders used for analysis, but there also is some evidence that the bias is stronger against African American males. We have 4 possible next steps for further analysis on this subject. First, we'd want to try more combinations of analysis with gender, such as direct effects or unaware effects with new structural causal models. Second, it would be very valuable to implement a technique from the paper of counterfactual fairness to make all 3 DAGs we use more fair. Third, we can directly test for unobserved confounders of race in the unaware model. And finally, using more categorical variables instead of as many binary variables, especially for race, would be very valuable.